In the summer of 1947, 13 warships sliced through the freezing waters of the Southern Ocean. They carried nearly 5,000 men, 25 aircraft, and enough supplies for 6 months of operations in the most hostile environment on Earth. Operation Highjump, the largest expedition to Antarctica in history, had been meticulously planned. Yet 69 days after it began, the fleet turned back. 3 men were dead. Admiral Richard Byrd, the expedition's leader, made cryptic statements upon his return that would echo through the decades. What happened in those waters remains contested to this day. Before we jump back in, tell us where you're tuning in from, and if these history tales fascinate you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Antarctica holds a peculiar place in human consciousness. It is the only continent with no indigenous population, no permanent human settlement, no native land mammals. 7.1 million square miles of ice reaching depths of 4.8 kilometers in places. Temperatures plunge to minus 89.2 degrees Celsius. Winds exceed 320 kilometers per hour. The continent stores 70% of Earth's fresh water as ice. If all of it melted, global sea levels would rise 58 meters. Yet despite, or perhaps because of its extreme remoteness, Antarctica has become a canvas for extraordinary claims. Hidden Nazi bases, secret UFO landings, ancient civilizations buried beneath the ice, hollow Earth entrances. Among these legends, one story possesses unusual persistence: that Germany established a permanent facility in Antarctica during World War II, a refuge where top Nazi officials fled as the Reich collapsed, where advanced technology was developed in secrecy, and where remnants might remain to this day. Consider the raw facts that feed this narrative. In 1938, a German expedition flew over what they called Neuschwabenland, dropping aluminum markers topped with swastika flags across 600,000 square kilometers of territory. German submarines operated in southern waters during the war. Admiral Karl Dönitz, commander of Germany's U-boat fleet, spoke of an impregnable fortress and a paradise-like oasis in Antarctica. After the war ended, rumors circulated of German submarines arriving in Argentina with mysterious cargo. Admiral Byrd's Operation Highjump, launched in 1946, involved military force that seemed excessive for a simple research mission. These facts exist. They are documented. Yet the interpretation of what they mean diverges dramatically. The legend appeals to something deep in our nature. The idea that history harbors secret chapters, that official narratives conceal hidden truths, that remote places protect extraordinary secrets. Antarctica's very inaccessibility makes it an ideal setting for such speculation. Few people will ever visit. Direct verification remains difficult. The continent's vast white emptiness invites projection of our fears and fascinations, but facts exist beyond narrative interpretation. Physical principles govern what is possible. Evidence accumulates through patient investigation, and the actual story of Antarctica, what we have discovered there, what continues to be revealed, exceeds any legend in wonder and significance. Consider what we know with certainty. Antarctica was not always frozen. Fossils of temperate forests exist there. Coal deposits preserve ancient swamps. The continent drifted from more northerly latitudes over millions of years, eventually settling over the South Pole where ice accumulated. This ice records Earth's atmospheric history. Air bubbles trapped in ancient layers preserve samples of atmospheres from 800,000 years ago. By analyzing these bubbles, we read climate story across timescales that dwarf human civilization. Beneath the ice lie lakes, not frozen solid but liquid water, kept from freezing by geothermal heat from below and the insulation of kilometers of ice above. Lake Vostok, discovered beneath Russia's Vostok Station, contains water that has been isolated from the surface for 15 million years. It is one of Earth's largest lakes, comparable in size to Lake Ontario, yet hidden completely from view until radar revealed its presence. The temperature of this water reaches -3 degrees Celsius liquid, only because of the immense pressure above it. What life might exist in those depths evolved in isolation longer than most modern species have existed on Earth's surface. Antarctica's ice sits atop a landscape as varied as any continent. Mountain ranges reach elevations of 3,000 meters. Valleys cut deep into bedrock. Volcanoes remain active. Mount Erebus, standing 3,794 meters high, contains a permanent lava lake that bubbles and churns year-round. The Gamburtsev Mountains, comparable to the Alps in scale, were completely unknown until 1958 when seismic surveys detected them buried under ice. The continent drives global climate systems. Dense, cold water forms along the Antarctic coast and sinks to the ocean floor, initiating circulation patterns that affect every ocean basin. The ice sheet's high albedo reflects solar radiation back to space, cooling the planet. Changes in Antarctic ice influence sea levels worldwide. Understanding this continent is not an academic exercise. It matters for the future of coastal cities where billions of people live. 47 nations have signed the Antarctic Treaty, agreeing to use the continent only for peaceful scientific purposes. Territorial claims are frozen. Military operations are prohibited. Environmental protection is mandated. This represents one of humanity's most successful international cooperations, rivals setting aside competition to preserve a place for knowledge and discovery. Yet this genuine wonder competes with legend. The Nazi base theory persists, mutating and adapting as new information emerges. Proponents cite satellite imagery showing geometric shapes beneath the ice. They reference declassified documents that mention Antarctica. They point to maps, supposedly showing ice-free coastal areas. They invoke advanced technology, flying saucers built by German engineers, anti-gravity devices tested in secret facilities. The legend serves purposes beyond historical speculation. It provides simple explanations for complex events. It attributes agency to hidden forces, making the chaotic more comprehensible. It sustains engagement with a region most people experience only through images and reports. It expresses anxieties about government secrecy, wartime trauma, and the possibility that darkness survived defeat. But belief and truth remain distinct. What we wish to be true differs from what evidence supports, and the evidence, examined carefully, tells a story quite different from the legend. Operation Highjump was real. Its mission was documented. The ship's aircraft and personnel are matters of record. Admiral Byrd commanded the expedition. All of this is true. What the operation actually accomplished, why it ended early, and what happened during those 69 days in the Antarctic summer of 1947 can be determined through documentation, participant accounts, and physical evidence. The German expedition of 1938 occurred. Photographs show the aircraft, the markers, the flags. We know the routes they flew, the areas they surveyed, the maps they produced. These historical facts exist, but what they signify requires context, understanding Germany's territorial ambitions, the nature of Antarctic claims in that era, and what the expedition actually accomplished versus what is attributed to it decades later. Every element of the Nazi base theory, the submarine arrivals, the mysterious statements, the post-war sightings, the supposed evidence can be examined against physical constraints, historical documentation, and engineering realities. This is not about debunking for its own sake. It is about understanding what actually happened, distinguishing genuine mystery from misinterpretation, and recognizing that reality, properly comprehended, offers more wonder than any fabricated narrative. Antarctica tests the limits of human endurance and ingenuity. Every research station there represents a triumph of engineering and logistics. Constructing even a small facility requires years of effort, millions of dollars, constant resupply, and accepts harsh constraints on what is possible. These limitations were more severe in the 1940s. Technology was less capable, materials were heavier, energy requirements were harder to meet. The isolation was more absolute. When we calculate what would have been necessary to establish and maintain a secret base in Antarctica during World War II, the tonnage of materials, the fuel requirements, the construction timeline, the number of workers needed, the supply chain logistics, we confront numbers that dwarf even major military operations of that era. These calculations are not speculative. They derive from known principles of thermodynamics, structural engineering, and human physiology in extreme cold. The question is not whether a hidden base is improbable. The question is whether it is physically possible, given constraints that no amount of secrecy can circumvent. Ice behaves according to principles. Extreme cold imposes requirements. Distance cannot be willed away, and evidence or its absence speaks regardless of what we wish to believe. This narrative will follow multiple threads. We will examine the historical record of German Antarctic activities, separating documented expeditions from attributed ones. We will detail Operation Highjump's actual objectives and outcomes, comparing official reports with later reinterpretations. We will calculate concrete requirements for Antarctic construction, showing why even modern bases remain small and costly. We will explore what Antarctica genuinely offers, discoveries that exceed fiction in significance. We will project into the future, examining how the continent transforms and what mysteries await. And we will reflect on why legends endure, what they reveal about human cognition, and how critical thinking coexists with wonder. The frozen continent invites both speculation and investigation. We can choose which path to follow. One path leads through echo chambers of confirmation bias, connecting scattered data points into predetermined patterns, finding conspiracy where complexity exists. The other path requires patience, humility before evidence, willingness to be surprised by what careful investigation reveals, and recognition that genuine understanding often begins by admitting ignorance. Antarctica remains mysterious, not because Nazis built bases there, but because it contains phenomena we are still working to comprehend. Lakes isolated for millions of years, ancient climates preserved in ice, landscapes completely hidden beneath frozen miles, life thriving in conditions that should be sterile, processes that influence the entire planet, playing out in a place few humans will ever witness directly. The story we are about to explore involves submarines and expeditions, but also thermodynamics and logistics. It encompasses wartime operations and modern remote sensing. It requires examining both historical documentation and contemporary Antarctic research. The narrative moves between past events and present understanding, between specific incidents and broad principles, between human drama and physical constraints. Truth emerges not from selecting facts that confirm pre-existing beliefs, but from following evidence wherever it leads, accepting conclusions even when they disappoint expectations, and recognizing that the actual story, messy, complex, occasionally mundane, holds more meaning than any simplified legend. The frozen continent awaits, not as a repository of secret history, but as a place where patient investigation reveals wonders that no conspiracy theory can match, where international cooperation demonstrates humanity's best impulses, where scientific dedication pursues understanding across decades and generations, where genuine mysteries remain, not because evidence is hidden, but because reality possesses depths we are still learning to fathom. Let us begin at the beginning with Germany's actual presence in Antarctica, before war, during conflict, and in the aftermath. Let us examine what is documented, what is known, what is claimed, and where these categories diverge. The truth will be more nuanced than legend suggests, but it will be, in its own way, remarkable. The relationship between Germany and Antarctica did not begin with conspiracy. It began with whales. In the early 20th century, whale oil was liquid gold. It fueled lamps, manufactured soap, produced glycerin for explosives, and lubricated machinery. Antarctic waters teemed with whales, blue whales, fin whales, humpbacks, and right whales, species that had been hunted to near extinction in northern waters but still thrived in the Southern Ocean. Norway dominated Antarctic whaling, operating factory ships that processed catches at sea, avoiding the need for shore stations and the territorial complications they involved. Germany, recovering from World War I and rebuilding its industrial capacity, needed access to whale oil. Norwegian whaling companies controlled the supply. German industrialists wanted independence from this monopoly, and so German attention turned southward. In 1925, a German whaling expedition ventured to Antarctic waters. It was not successful. The ship was ill-suited for conditions. The crew lacked experience, but it demonstrated interest. Through the late 1920s and early 1930s, German whaling operations expanded. By the mid-30s, German factory ships processed thousands of whales each season. This was commerce, not conquest. Economic necessity, not ideological ambition. Yet commerce and politics intertwine. As Nazi power consolidated in Germany through the 1930s, the regime viewed self-sufficiency as strategic imperative. Dependence on foreign resources was vulnerability. Whale oil imports from Norwegian-controlled operations rankled. The idea of German-claimed Antarctic territory, where German whaling could operate without foreign permission, gained appeal. Norway had claimed Bouvet Island in 1927 and Peter I Island in 1929. Britain claimed vast sectors of Antarctica. France held Adelie Land. In 1933, Norway claimed even more, the area between 20 degrees west and 45 degrees east longitude, calling it Queen Maud Land. This claim encompassed prime whaling waters and potential shore station sites. Germany had made no Antarctic claims. As the 1930s progressed, this began to seem like an oversight worth correcting. The German Antarctic expedition of 1938 and 39 was proposed by Hermann Göring and approved by Hitler. Its stated purpose was to investigate the feasibility of establishing a German whaling station and to scout locations that might support German territorial claims. The expedition was not secret. It was announced. The ship, the Schwabenland, a converted freighter equipped with catapults for launching aircraft, departed Hamburg on December 17, 1938. Captain Alfred Richer commanded the expedition. The crew numbered 82 men. The ship carried 2 Dornier flying boats, the Passat and the Boreas, designed for long-range reconnaissance. These aircraft could be launched from catapults on the ship and land on water upon return. The technology was sophisticated for its time, allowing aerial survey of regions that would take months to explore on foot or by ship. The Schwabenland arrived at the Antarctic coast on January 19, 1939. Over the next 3 weeks, the aircraft flew 15 survey flights, covering approximately 600,000 square kilometers of previously uncharted territory. The pilots photographed the landscape below endless ice, mountain ranges, coastal features, and from the aircraft they dropped aluminum poles topped with swastika flags. These markers were intended as territorial claims, symbols of German presence in a remote region. The photographs from these flights still exist. They show the aircraft, the crew, the landscape of mountains and ice. The flight logs document routes, altitudes, weather conditions. The maps produced from the survey detail coastlines and interior features. This expedition is not disputed. The question is what it meant and what it accomplished. The region surveyed was named Neuschwabenland New Swabia, after the ship and the Swabian region of Germany. The coordinates were recorded approximately between 10 degrees west and 20 degrees east longitude, from the coast inland to about 75 degrees south latitude. The area overlapped with Norway's claim to Queen Maud Land, which was precisely the point. Germany was asserting territorial interest in the same region Norway had claimed. But assertion and possession differ fundamentally. Dropping markers from aircraft does not constitute effective occupation under international law. No German personnel remained in Antarctica after the expedition departed. No stations were established. No infrastructure was built. The expedition mapped and photographed, then left. The Schwabenland returned to Germany in April 1939. The expedition was deemed successful. Plans were discussed for a follow-up mission in 1939-40, which would establish an actual shore station and cement German presence. These plans were detailed, supplies were allocated, personnel were selected. Then, on September 1st, 1939, Germany invaded Poland. World War II began. The planned second expedition was cancelled. The Schwabenland was requisitioned for military service. The maps and photographs from the first expedition were filed away. Germany's Antarctic ambitions became irrelevant as Europe descended into war. This is the documented German presence in Antarctica before and during World War II. One expedition, 3 weeks in early 1939, aerial surveys and marker drops, no permanent stations, no return missions. That is what the historical record supports. Yet the legend builds from this foundation. If Germany was interested enough to send an expedition in 1939, proponents argue, surely they returned during the war when secrecy would have been easier. If they claimed territory, surely they intended to use it. If plans existed for a station, surely those plans were executed covertly. These logical leaps assume that interest equals action, that intention guarantees implementation, and that absence of evidence suggests evidence is hidden rather than that events did not occur. But war transforms priorities. Resources become scarce. Ambitious plans yield to immediate necessities. The Germany of 1939, still at peace and planning for a future where Antarctic whaling might matter, was very different from the Germany of 1940 through 45, fighting for survival on multiple fronts. To understand what Germany could or could not have done in Antarctica during the war, we must understand Germany's actual situation. Through 1940 and 41, Germany achieved stunning military successes. Poland fell quickly. France was defeated. Much of Europe was occupied. Britain stood alone. The war seemed winnable. But even at the height of success, Germany faced resource constraints. Oil supplies were limited. Steel production, while substantial, could not meet all military needs simultaneously. Shipbuilding competed with tank production, aircraft manufacturing with submarine construction. Every choice involved trade-offs. The invasion of the Soviet Union in June 1941 changed everything. The Eastern Front became a vast drain on German resources. Millions of men, thousands of tanks and aircraft, enormous quantities of fuel and ammunition poured into operations that, after initial advances, bogged down into brutal attrition. The Wehrmacht reached the outskirts of Moscow in December 1941, then was pushed back by Soviet counterattacks and brutal winter conditions. By 1942, Germany was fighting in Russia, North Africa, and the Atlantic. U-boats hunted Allied convoys while Allied aircraft hunted U-boats. Resources grew tighter. Fuel shortages became chronic. Albert Speer, appointed Minister of Armaments in February 1942, focused on rationalizing production, eliminating inefficiencies, and maximizing output of essential military equipment. In this context, consider what an Antarctic expedition would require. A ship either diverted from military service or specially built, Fuel for the voyage, tens of thousands of litres for a round trip covering over 20,000 kilometres. Supplies for construction materials, tools, equipment, all of which had military applications closer to home. Personnel, skilled workers, engineers, scientists, all desperately needed elsewhere. And for what purpose? Antarctica offered no strategic value to the war effort. It was thousands of kilometers from any front. It held no resources Germany could exploit with wartime technology. It contributed nothing to defeating enemies or securing occupied territories. The argument is sometimes made that precisely because Antarctica was so remote, it could serve as a refuge, a place to retreat if Germany lost, a location to preserve Nazi leadership, technology, or ideology. But this reasoning reverses cause and effect. A refuge only makes sense if you anticipate defeat. Through most of the war, Germany was not planning for defeat. They were planning for victory. Resources went to achieving that victory, not preparing for its failure. When did Germany's leadership begin to seriously contemplate defeat? Not in 1940, not in 1941, perhaps in late 1942, after Stalingrad, though even then the regime maintained public confidence. More realistically, by late 1943 and into 1944, as the Eastern Front collapsed, Italy surrendered, and Allied forces prepared for the Normandy invasion. At that point, resources were completely exhausted. Germany was producing aircraft faster than pilots could be trained to fly them. Fuel shortages, grounded planes. Tank production continued, but divisions lacked the fuel to operate. Cities were being bombed around the clock. Every shipyard, every factory, every ounce of steel was dedicated to immediate military necessity. The idea that in this context, with Soviet armies advancing from the east, Allied forces landing in France, cities burning, supply lines collapsing, Germany somehow assembled an Antarctic expedition, diverted ships and submarines, transported construction materials, established a base, and maintained it through the war's end, requires believing that a regime focused entirely on short-term survival somehow executed a long-term project requiring years of effort and massive resources. Submarines are mentioned frequently in the legend. German U-boats had remarkable range. Type 9 U-boats could travel nearly 23,000 nautical kilometers without refueling. They operated in the Indian Ocean, off the coast of Africa, in the Caribbean. Surely, the argument goes, they could reach Antarctica. Range and capability differ from mission and evidence. Yes, German submarines could physically reach Antarctic waters. Several did so during the war, operating in the southern Atlantic and Indian Oceans. These operations are documented. The boats, their commanders, their missions, all are matters of record. U-boat operations were meticulously logged. Every patrol generated reports, areas transited, enemy vessels sighted, attacks made, damage sustained, fuel consumed. These reports exist in archives. They document where U-boats went and what they did. None describe Antarctic base construction or supply missions. After the war ended, some German submarines fled to Argentina rather than surrender to Allied forces. These arrivals were documented by Argentine authorities. The boats and their crews were interned, inspections were conducted, cargo manifests were checked. No mysterious materials or personnel were found that would suggest Antarctic connections. The legend sometimes invokes Admiral Karl Dönitz, commander of Germany's U-boat fleet and briefly Hitler's successor after the Führer's suicide. Dönitz made statements referencing a fortress and an oasis in Antarctica. These quotes appear repeatedly in discussions of the Nazi base theory. The actual statements require context. Dönitz spoke to submarine crews about the importance of secure bases. He used metaphorical language about impregnable positions. Some of these comments have been interpreted as references to Antarctic facilities. but no contemporary documentation links them specifically to Antarctica. The interpretation came later, after the legend was established. What we know with certainty, Germany sent one expedition to Antarctica before the war. That expedition surveyed and claimed territory but established no permanent presence. During the war, German submarines operated in southern waters, but no verified missions to Antarctica occurred. After the war, some submarines fled to Argentina, but no evidence of Antarctic connections emerged from their inspection. The gap between this documented history and the elaborate legend is vast. The legend fills this gap with speculation, assumption, and creative interpretation of ambiguous evidence. It attributes sophisticated planning to a regime that was improvising desperately. It assumes competence and foresight when history shows chaos and delusion. It imagines long-term projects when reality was day-to-day crisis management. Understanding what Germany did in Antarctica requires understanding what Germany could do, given actual constraints. It requires examining evidence critically, distinguishing between confirmed events and later attributions, and recognizing that absence of documentation for extraordinary claims is significant. Germany's actual Antarctic footprint was shallow and brief. One expedition, 3 weeks, aerial surveys, no hidden bases, no secret refuge, no preserved Nazi remnants. Just an attempt to claim whaling territory that was abandoned when war made such concerns irrelevant. The documented record is clear. The question is, why this clarity fails to dispel the legend? Why conspiracy theories persist despite contradicting evidence? And what this reveals about how humans construct and maintain belief in the face of facts that suggest otherwise. These questions extend beyond Antarctic history into the nature of how we think, what we want to believe, and how stories shape our understanding of the world. The largest expedition to Antarctica in history began with practical concerns, not mystery. World War II ended in August 1945. The United States emerged as a global superpower, but also faced immediate challenges. The military had expanded to over 12 million personnel. Ships, aircraft, and equipment manufactured for war now required peacetime purposes. Millions of servicemen needed to transition to civilian life, but the military wanted to retain operational capabilities and technical expertise. Antarctica offered an opportunity. The continent remained largely unexplored. Its strategic value in a potential conflict was uncertain. Weather patterns originating there affected global systems, but meteorological understanding was limited. The logistics of polar operations, crucial if future conflicts extended to Arctic regions, where the United States and Soviet Union faced each other across the top of the world, remained untested at scale. And so Operation Highjump was conceived. The official name was the United States Navy Antarctic Developments Program. The objectives were documented in planning materials: test equipment in extreme cold, train personnel in polar operations, establish a research station, expand cartographic knowledge, and determine the feasibility of maintaining bases in Antarctica. Admiral Richard Byrd was appointed to lead the expedition. Byrd had Antarctic experience. He had led expeditions in 1928 through 30 and 1933 through 35. He had flown over the South Pole in November 1929, becoming one of the first humans to do so. He was a legitimate explorer, a naval officer, and a public figure. His involvement gave the operation credibility and public interest. The scale was unprecedented. 13 ships, the icebreakers Northwind and Burton Island, the aircraft tender Philippine Sea, the submarine Senate, the destroyer Brownson, the seaplane tender Currituck, supply vessels and cargo ships, 4,700 men, 25 aircraft including reconnaissance planes, helicopters, and ski-equipped transports. Enough supplies for 6 to 8 months of operations. The fleet departed Norfolk, Virginia, in early December 1946. The journey south took weeks. The ships crossed the equator, continued through the southern Atlantic, and approached Antarctica in early January 1947. The Antarctic summer was beginning. The brief window when temperatures rose above -20 degrees Celsius and daylight lasted nearly 24 hours. The operation was divided into 3 groups. The central group, led by Admiral Byrd from the command ship Mount Olympus, would establish Little America 4, a base near the site of Byrd's previous expeditions on the Ross Ice Shelf. The western group would explore the area around the Antarctic Peninsula. The eastern group would survey the coastline between Ross Sea and the Indian Ocean sector. This plan was ambitious but straightforward. The ships would support aircraft operations, allowing extensive aerial photography and mapping. Ground parties would establish weather stations and test equipment. Data would be collected on everything from ice conditions to penguin populations. When the Antarctic summer ended and temperatures dropped, the fleet would withdraw. What actually happened follows the plan almost exactly, with one significant deviation. The operation lasted only 69 days instead of the planned 6 to 8 months. This early termination is the foundation of much speculation. Why would such an elaborate, expensive operation be cut short? What happened that forced early withdrawal? The questions seem to invite dramatic answers. The official explanation is documented in multiple sources. 3 men died in accidents. On December 30th, 1946, before the fleet even reached Antarctica, a plane crashed during a storm, killing 3 crew members. On January 8, 1947, a seaplane crashed in the Ross Sea, killing 3 more. These deaths were not mysterious. They were the kind of accidents that occur in dangerous operations, with thousands of personnel operating complex equipment in extreme conditions. The weather was worse than anticipated. Antarctic conditions are never benign, but the 1946-47 summer proved particularly harsh. Storms repeatedly grounded aircraft. Sea ice was thicker than expected, impeding ship movements. The icebreakers worked constantly to keep channels open. Visibility was frequently poor, hampering aerial surveys and photography. Equipment failures occurred. Aircraft designed for temperate climates struggled with extreme cold. Instruments froze. Engines failed. Rubber seals became brittle and cracked. Skis designed for snow landing broke on hard ice. Each failure required repairs or workarounds, consuming time and resources. Supply logistics proved challenging. The ships carried extensive supplies, but consumption exceeded planning estimates. Fuel for heating, aircraft operations, and ship propulsion depleted faster than anticipated. Food supplies were adequate, but required careful rationing if the operation extended its timeline. By late February, operational objectives were largely met. Little America 4 was established. Extensive aerial photography had been completed, over 70,000 photographs, covering millions of square kilometers. Coastal surveys had mapped previously uncharted regions. Equipment had been tested under real conditions. Training objectives for personnel had been achieved. Admiral Byrd, Admiral Richard Byrd, who commanded the task force, and other senior officers evaluated the situation. They could extend operations, but doing so would push into late summer and early autumn when conditions deteriorate rapidly. The risk of ships becoming trapped in sea ice was real. Personnel were exhausted. Several men had been injured. 3 were dead. The decision was made to withdraw. The operation had accomplished most of its objectives in compressed time frame. Remaining longer would increase risks without proportional benefits. On February 22, 1947, the fleet began its return journey. By late March, the ships arrived back in United States waters. This timeline is documented in official reports, ship logs, personal accounts from participants, and contemporary fleet. News coverage. The operation occurred in full view. Reporters accompanied the expedition. Photographs were published. Updates were broadcast. There was no secrecy about the operation itself or its termination. Yet Admiral Byrd's statements upon return have been interpreted as hinting at something more. He gave interviews to newspapers in Chile and Argentina during the fleet's journey home. Some of his comments were dramatic. He spoke of Antarctica's importance to security. He mentioned encountering challenges. Some quotes reference enemies that could strike at incredible speeds. These statements require context. Byrd was a public figure, aware of his audience. He had just completed an operation that cost millions of dollars. Justifying that expense meant emphasizing the strategic significance of Antarctic exploration. Speaking to South American press, he naturally emphasized regional connections and security implications. The quote about enemies attacking at incredible speed has been interpreted as referencing advanced aircraft or technology. The actual statement, when read in full context, appears to reference the hypothetical threat of long-range bombers or missiles that could use polar routes. This was a legitimate concern in the emerging Cold War. Both the United States and Soviet Union were developing long-range strategic bombers. Byrd was arguing for continued Antarctic research to understand weather patterns and establish bases that could provide warning of such attacks. The interpretation that he was describing actual encounters with hostile forces requires reading implications into words that have straightforward explanations. This is a pattern we will see repeatedly. Ambiguous statements interpreted to support predetermined conclusions rather than evaluated in context. What did Operation Highjump actually accomplish? The photographic record alone was substantial. Over 70,000 aerial photographs covered approximately 60% of the 30 Antarctic coastline. These images revealed mountain ranges, coastal features, and inland topography that had never been mapped. The photographs were analyzed, and charts were produced that remained the best available maps of many Antarctic regions for decades. Weather data was collected at multiple locations. Measurements of temperature, wind speed, barometric pressure, and ice conditions provided baseline information for climatological studies. Radio propagation tests examined how electromagnetic signals behaved in polar regions critical for communications and navigation systems. Equipment testing yielded practical lessons. Aircraft required modifications for cold weather operations. Skis needed different materials and designs. Heating systems needed redundancy. Fuel required additives to prevent gelling. Clothing and shelter had to meet higher insulation standards. These lessons were documented and applied to subsequent polar operations. Training outcomes were significant. Thousands of personnel gained experience operating in extreme cold. Logistics officers learned how to supply remote bases. Pilots understood the challenges of polar navigation. Medical officers treated cold injuries and studied their prevention. This experiential knowledge proved valuable when the United States established permanent Antarctic stations in subsequent years. The operation cost approximately $700,000, substantial money in 1947, but a fraction of military budgets. For this investment, the Navy gained operational experience, scientific data, and cartographic information. The operation achieved its documented objectives. What it did not do was engage Nazi forces, discover hidden bases, or encounter advanced technology. No combat occurred, no mysterious installations were found, no evidence of German presence was detected. The operation was exactly what official documents described: a large-scale expedition to explore, map, and test polar operations. The submarine? Senate's participation is sometimes cited as evidence of military objectives. Why bring a submarine to Antarctica unless you expected underwater threats? The answer lies in the mission objectives. The submarine was there to test operations under ice, evaluate acoustic conditions in polar waters, and conduct oceanographic surveys. Submarines were emerging as crucial strategic weapons in the early Cold War. Understanding how they performed in extreme conditions was a legitimate research objective. The secrecy surrounding certain aspects of the operation is also invoked. Some operational details were classified. Some photographs were restricted. Doesn't this suggest hidden purposes? Military operations routinely classify information, not because of conspiracies, but because of standard security procedures. Ship movements, communication frequencies, equipment capabilities, and operational techniques are classified to prevent potential adversaries from gaining intelligence advantage. The fact that some Operation Highjump materials were classified initially is unremarkable. What matters is that documents have been declassified over subsequent decades, allowing detailed examination of what the operation actually entailed. Those declassified documents are extensive. They include planning materials, operational orders, ship logs, aircraft reports, photographic records, personnel accounts, scientific data, and post-operation analyses. This documentation describes an ambitious but straightforward expedition that accomplished most objectives before withdrawing due to practical considerations. Conspiracy theories thrive on absence of evidence, interpreting it as evidence of concealment rather than evidence of non-occurrence. But in this case, abundant evidence exists. The challenge for conspiracy theorists is not that documentation is missing, but that existing documentation contradicts their narrative. They respond by claiming documents are forged, incomplete, or deliberately misleading. They argue that the real operation occurred alongside the documented one, hidden within it. They suggest that some participants knew the truth but were silenced. These claims are unfalsifiable. Any evidence contradicting them is dismissed as part of the cover-up. But consider the logical implications. Keeping such a secret would require thousands of people maintaining absolute silence for decades. No deathbed confessions, no leaked documents beyond official ones, no physical evidence, no contemporary observers noticing discrepancies. Perfect operational security maintained across thousands of participants, many of whom returned to civilian life where they had no ongoing obligation to maintain military secrecy. This level of conspiracy coordination is implausible. Not impossible in absolute terms, but so unlikely given human nature that it requires extraordinary evidence to be credible. And that evidence does not exist. What exists are ambiguous statements interpreted creatively, official documents dismissed as cover stories, and absence of evidence treated as proof of concealment. Operation Highjump was remarkable for what it was, the largest Antarctic expedition ever mounted, an operation that mapped vast regions, tested equipment and techniques, and trained thousands of personnel in polar operations. It demonstrated that large-scale operations were feasible in Antarctica, even with 1940s technology. It provided foundation for subsequent United States Antarctic programs, including establishment of permanent research stations. The operation's early termination was regrettable but understandable. Deaths and harsh conditions made extension risky. Primary objectives had been met, resources were depleting. The decision to withdraw was prudent military leadership, not evidence of defeat or discovery. Admiral Byrd's statements were those of a career officer and explorer, emphasizing the strategic importance of his field. His words have been mined for hidden meanings, but straightforward interpretation requires no conspiracy. He was advocating for continued Antarctic research and warning about legitimate Cold War security concerns. The operation's legacy is visible in modern Antarctic infrastructure. The lessons learned informed design of later stations. The maps produced guided subsequent expeditions. The operational techniques tested became standard procedures. Operation Highjump was a success by its own criteria, even if it lasted only 69 days instead of 6 months. Understanding what actually happened requires reading the extensive documentation with care, placing statements in context, recognizing that operations in extreme environments face predictable challenges, and accepting that sometimes explanations are straightforward rather than dramatic. The legend persists because it offers narrative satisfaction that reality does not provide. A massive operation terminating early invites the question why, and dramatic answers feel more compelling than prosaic ones. Deaths and difficult conditions suggest conflict, and conflict suggests opponents. Admiral Byrd's dramatic phrasing invites interpretation beyond his likely intent, but feeling compelling and being true are different standards. Operation Highjump's story is well documented. The mystery is not what happened, but why clear documentation fails to displace speculation. That question leads us into psychology and epistemology, how humans form beliefs, what makes some narratives stickier than others, and why conspiracy thinking persists despite contradicting evidence. Before we explore those questions, we must complete the investigation by examining whether the Nazi base theory is physically plausible. Setting aside historical documentation for a moment, could such a base have been built and maintained with 1940s technology? What would it require? What constraints would it face? These questions have concrete answers rooted in engineering, thermodynamics, and logistics. The calculations are revealing. Let us consider what building a base in Antarctica actually requires. Begin with heat. The human body maintains a core temperature of 37 degrees Celsius. When ambient temperature drops to minus 60 degrees Celsius, a typical Antarctic winter, reading the temperature differential is nearly 100 degrees. Heat flows from warm to cold. A heated structure in Antarctica loses warmth constantly through every surface exposed to outside air. Calculate the heating requirement for even a small facility. A structure measuring 20 meters by 10 meters by 3 meters, 600 cubic meters of interior space, would need continuous heating to maintain livable temperatures. Insulation reduces but does not eliminate heat loss. Even with excellent insulation, such a structure would require approximately 50 kilowatts of continuous heating power during winter. 50 kilowatts for 8 months of Antarctic winter equals nearly 300,000 kilowatt-hours of energy. That energy must come from somewhere. In the 1940s, options were limited. Burn fuel or use electricity generated by burning fuel. Diesel fuel contains approximately 10 kilowatt-hours of energy per litre. 300,000 kilowatt-hours would require 30,000 litres of diesel fuel per winter just for heating this one small building. Scale up to a facility housing 50 people, the minimum for a viable base. Multiple buildings for living quarters, workshops, storage, generators. Total heating requirements multiply. 50,000 litres of fuel per winter becomes a conservative estimate. That fuel must be transported to Antarctica, stored without freezing, and burned continuously. Now, add electricity for lighting, cooking, communications, equipment operation. Add fuel for vehicles and aircraft. Add fuel for heating during construction, which would occur over multiple Antarctic summers. The total fuel requirement reaches hundreds of thousands of litres. Every litre must be shipped across 10,000 kilometres of ocean. In the 1940s, ships travelled at 15 to 20 knots. The voyage from Germany to Antarctica would take weeks each direction. The fuel consumed by the transport ship during this voyage would be substantial thousands of litres for a single round trip. Consider construction materials. A permanent structure in Antarctica requires robust design to withstand extreme cold, high winds, and massive snow loads. Wood becomes brittle in extreme cold. Steel conducts heat away rapidly unless heavily insulated. Concrete is difficult to work with in freezing temperatures. Modern Antarctic stations use specialized materials and prefabricated components. Construction still takes years. The Amundsen Scott South Pole Station, rebuilt in the early 2000s, required over a decade of planning and construction. The cost exceeded $150 million, and that was with modern equipment, contemporary materials, air transport for personnel and supplies, and decades of engineering experience. A 1940s expedition would have had none of these advantages. Materials would be heavier and less efficient. Transport would be slower. Construction techniques would be more labor-intensive. The engineering challenges would be more severe. How many workers would be needed? Construction in extreme cold requires more personnel than temperate construction. Work proceeds slowly. Frequent breaks are necessary to prevent cold injury. Each worker requires food, water, shelter, heating. 50 construction workers, rotating shifts to maintain continuous progress during the brief summer season, would be a minimum estimate. Those workers would need to be housed and supplied throughout their time in Antarctica. Each person requires approximately 2 kilograms of food per day. 50 workers for 6 months. The duration of 2 Antarctic summers with a winter interval would consume 18,000 kilograms of food. Add water, medical supplies, clothing, equipment, and the logistics become daunting. Where would this base be built? The interior of Antarctica is most isolated but also most hostile. Temperatures drop below -80 degrees Celsius in winter. Altitude reaches 3,000 meters or more in places, causing altitude effects. Supply becomes nearly impossible during winter months when aircraft cannot operate. Coastal locations are more accessible but less hidden. Ships can approach during summer. Aircraft can land on sea ice. But visibility from sea means vulnerability to discovery. And coastal locations experience fierce katabatic winds, gravity-driven airflows that cascade down from the interior, reaching speeds exceeding 150 kilometers per hour. The legend sometimes proposes underground facilities to solve these problems. Building underground provides insulation and concealment, but excavating in ice or frozen ground requires enormous energy. Ice must be melted or cut away. The resulting water must be removed or drained. The excavation creates heat, which melts surrounding ice, which then refreezes. Structural stability requires constant maintenance. Modern ice drilling technology can create holes through kilometers of ice, but these are narrow boreholes, not habitable spaces. Creating an underground chamber large enough for human occupation would require moving thousands of tons of ice. The energy requirement would exceed surface construction. Even if construction were somehow accomplished, maintenance would be ongoing. Snow accumulation in Antarctica averages 10 to 50 centimeters per year. A surface structure would be buried within decades. Entrances must be kept clear continuously. Ventilation shafts require constant attention. Let us examine the supply chain required to sustain such a base. 50 people require approximately 100 kilograms of food per day. Annually, that equals 36,000 kilograms, 36 tons. Add fuel, spare parts, medical supplies and equipment, and annual supply requirements reach hundreds of tons. Transporting hundreds of tons to Antarctica requires either ships or aircraft. Ships can carry large cargo but are limited to summer operations when sea ice permits passage. A supply ship would need to visit annually, a voyage lasting weeks each direction, carrying crew and cargo, consuming fuel, maintaining secrecy despite departing from and returning to monitored ports. Aircraft could make multiple trips but would be limited by payload capacity. A large transport aircraft might carry 10 tons per trip. 36 tons of food alone would require 4 flights. Total annual supply needs could require dozens of flights, each crossing thousands of kilometers, each consuming thousands of liters of fuel, each requiring skilled crews and ground support. The notion that Nazi Germany, fighting for survival on multiple fronts, experiencing severe fuel shortages by 1943 and 44, collapsing militarily in 1945, somehow maintained such a supply chain is implausible. The resources required would rival major military operations. The diversion of ships, aircraft, fuel, and materials would be detectable. After the war, the scenario becomes no more plausible. Who would continue supplying a hidden base? Nazi sympathizers in South America? They would need ships, fuel, cargo, and coordination. They would need to explain where ships were going, what they were carrying, why they were gone for months. Port authorities would notice. Intelligence agencies would investigate. Consider detection probability. Modern satellite surveillance can detect structures as small as 1 meter across. Ground-penetrating radar can map subglacial topography, with resolution detecting cavities and anomalies. Infrared sensors can detect heat signatures. Even in the 1940s and 50s, aerial reconnaissance could photograph large areas. Weather stations, whaling operations, and scientific expeditions traversed Antarctic regions regularly. A facility large enough to house 50 people would have detectable signatures. Heat from generators and heating systems would create surface melting in surrounding snow. Ventilation would produce visible plumes in cold air. Aircraft operations would leave tracks on snow and ice. Radio communications would be detectable by monitoring stations. The legend proposes that the base was located in a particularly remote area, unknown to explorers. But Antarctica, while vast, is not infinite. By the 1950s, aerial surveys had mapped most coastal regions. By the 1980s, satellite imagery covered the entire continent. Current datasets image Antarctica with resolution sufficient to detect features larger than a few meters. The Gamburtsev Mountains, a range comparable to the Alps, remained unknown until 1958, not because they were impossible to find, but because they are buried under 4,000 meters of ice. Detection required seismic surveys, yet even these hidden mountains were eventually found. A surface or near-surface facility would be vastly easier to detect. Modern ground-penetrating radar surveys have mapped 98% of Antarctica's bedrock topography. These surveys detect bedrock depth, subglacial water, and significant density anomalies. A constructed facility would create detectable radar signatures. No such anomalies consistent with human construction have been found. The engineering analysis is conclusive. Building and maintaining a secret Antarctic base with 1940s technology would require resources Nazi Germany did not have. Logistics it could not sustain, and operational security it could not maintain. The physical requirements exceed what is historically plausible. The absence of evidence is precisely what we would expect if no such base existed. This conclusion does not rest on trusting authorities or accepting official narratives. It rests on physics, engineering, and arithmetic. Heat transfer is governed by thermodynamics. Construction requires materials and labor. Supply chains need transport and fuel. These requirements are quantifiable and verifiable. The legend cannot survive this quantitative scrutiny. It relies on vague assertions. They must have built it somehow, rather than concrete specifications. It invokes advanced technology without explaining how that technology was developed, manufactured, and deployed. It assumes unlimited resources when historical records show desperate scarcity. Mystery requires possibility. If something is physically impossible given known constraints, it is not mysterious. It simply did not happen. The Nazi Antarctic base theory fails this basic test, not because we lack imagination, but because reality imposes limits that no amount of speculation can overcome. Understanding these limits does not diminish Antarctica. The continent harbors genuine wonders that exceed any fabricated legend. What exists there is more remarkable than what is imagined, and those genuine discoveries await our exploration. Beneath 4 kilometers of ice, sealed from the surface for 15 million years, lies Lake Vostok. The lake is enormous, 250 kilometers long, 50 kilometers wide, covering an area comparable to Lake Ontario. The water reaches depths of 1,000 meters in places. Yet until 1996, when Russian scientists drilling ice cores detected an unexpected cavity, humanity had no idea this lake existed. The water temperature hovers around -3 degrees Celsius. It remains liquid because of immense pressure from the ice above and geothermal heat from Earth's interior below. The pressure exceeds 350 atmospheres, enough to raise water's freezing point and keep the lake liquid despite temperatures that would freeze surface water instantly. What lives in Lake Vostok? The question drives ongoing research. Samples from ice immediately above the lake contain bacteria species unknown elsewhere, adapted to extreme conditions, living in isolation longer than most species on Earth have existed. These organisms offer glimpses into how life adapts to extreme environments. The implications extend beyond Antarctica. Jupiter's moon Europa possesses a subsurface ocean beneath ice, possibly 20 kilometers thick. Saturn's moon Enceladus has geysers erupting from an ocean beneath its frozen surface. If life exists in Earth's subglacial lakes, it suggests life might exist in extraterrestrial ice-covered oceans. Techniques developed to explore Lake Vostok will be adapted to explore Europa's depths. Antarctica contains over 400 known subglacial lakes. Lake Vostok is the largest, but others dot the continent beneath ice. Each isolated, each potentially harboring unique ecosystems, each representing a natural laboratory for studying extremophile life. Move to the surface, to the dry valleys. Here, precipitation has not fallen for 2 million years. The valleys are ice-free despite lying within Antarctica. Katabatic winds sweep down from the interior, reaching speeds exceeding 100 kilometers per hour, preventing snow accumulation. Humidity approaches zero. The landscape resembles Mars more closely than anywhere else on Earth. Yet even here, life persists. Cryptoendolithic bacteria live inside sandstone rocks, obtaining water from rare fog, photosynthesizing in the thin bands of light that penetrate translucent stone. Nematode worms inhabit soil, surviving freezing by entering cryptobiosis, a state of suspended animation where metabolism ceases until conditions improve. These organisms expand our understanding of life's limits. If bacteria thrive inside dry valley rocks, perhaps life on Mars exists in similar refuges. If nematodes survive Antarctic freeze-thaw cycles, perhaps similar organisms could survive on planets with extreme temperature fluctuations. Consider bloodfalls. At the terminus of Taylor Glacier, iron-rich water emerges, staining ice a vivid red. This brine has been isolated from atmosphere for 1.5 million years, 17% salt, 4 times ocean salinity, yet harboring bacteria that metabolize iron and sulfur instead of oxygen. The ecosystem runs entirely on chemistry, independent of photosynthesis, demonstrating that life can persist without sunlight given alternative energy sources. Antarctica's ice cores preserve Earth's atmospheric history. Snow falls, layer upon layer, compacting into ice that traps air bubbles. Each bubble is a sample of ancient atmosphere, its composition, its temperature, its dust content. By drilling ice and analyzing bubbles, we read climate's story across 800,000 years. The data reveal patterns. Carbon dioxide levels oscillated between 180 and 300 parts per million throughout glacial cycles. Temperature correlated with carbon dioxide, higher gas concentrations coincided with warmer periods. These oscillations reflected orbital changes, affecting solar radiation to Earth received. Then industrialization began. Carbon dioxide levels rose past 300 parts per million in the 1950s. They exceeded 350 in the 1980s. They surpassed 400 in 2013. Current levels exceed 420 parts per million, higher than any point in the 800,000-year ice core record. This data does not predict specific outcomes, but it provides context. Current atmospheric carbon dioxide exceeds natural variability captured in ice cores. The rate of increase is unprecedented. Whatever consequences follow, we are conducting an experiment beyond the range of recent Earth history. Antarctica influences global climate through multiple mechanisms. The ice sheet's high albedo reflects 70 to 80% of incoming solar radiation back to space. Without this reflectivity, Earth would absorb more energy and warm further. As ice melts and darker ocean or land surface appears, albedo decreases, creating a feedback loop that accelerates warming. Dense, cold water forms along Antarctic coasts and sinks to the ocean floor, driving thermohaline circulation, the global conveyor belt that distributes heat and nutrients throughout ocean basins. Changes in Antarctic ice affect this circulation, with consequences for climate patterns, marine ecosystems, and fisheries thousands of kilometers away. The continent stores 26.5 million cubic kilometers of ice, 70% of Earth's fresh water. If all Antarctic ice melted, sea levels would rise approximately 58 meters. This will not happen quickly, but even partial melting has profound consequences. The West Antarctic ice sheet alone contains enough ice to raise sea levels by 3 to 5 meters. Mount Erebus stands 3,794 meters high, constantly active, containing a permanent lava lake that bubbles and churns. The volcano releases approximately 80 kilograms of gold as vapor each day, a gold that precipitates in the air and settles on snow. This is Antarctica's alchemy, turning volcanic heat into precious metal dust. Subglacial volcanism shapes ice from below. Volcanoes beneath West Antarctica produce heat that melts ice at the base of glaciers, creating water that lubricates ice flow. Understanding these volcanic systems helps predict ice sheet behavior, where melting might accelerate, where glaciers might destabilize. The Antarctic Treaty of 1959 stands as one of humanity's most successful international agreements. 47 nations have signed, agreeing to use Antarctica only for peaceful scientific purposes. Military activities are prohibited. Territorial claims are frozen. Environmental protection is mandated. Nuclear explosions and radioactive waste disposal are banned. This cooperation emerged during the Cold War when the United States and Soviet Union competed globally. Yet in Antarctica, rivals set aside conflict. Scientists from competing nations collaborate. Research stations share data. Rescue operations cross national boundaries. The continent demonstrates that cooperation is possible even amid geopolitical tension. Current Antarctic research spans disciplines. Climatologists study ice cores. Marine biologists survey southern ocean ecosystems. Astronomers operate telescopes at South Pole Station, where clear, dry air and 6 months of darkness provide exceptional observing conditions. Astrophysicists detect neutrinos using sensors embedded deep in ice. Geologists map subglacial topography and study volcanic systems. The IceCube Neutrino Observatory, buried under Antarctic ice at the South Pole, contains over 5,000 optical sensors distributed through a cubic kilometer of ice. Neutrinos, nearly massless particles that rarely interact with matter, occasionally collide with ice molecules, producing flashes of light that sensors detect. By analyzing these events, physicists study cosmic rays, supernovae, and fundamental particle physics. Antarctic astronomy benefits from unique conditions. The atmosphere is thin due to high altitude and extreme cold. Water vapor, which absorbs infrared radiation, is nearly absent. 6 months of continuous darkness allow uninterrupted observation. Telescopes at South Pole Station probe the cosmic microwave background, studying radiation from the early universe, measuring parameters that constrain cosmological models. The continent's biodiversity, while limited, is uniquely adapted. Emperor penguins breed during Antarctic winter, incubating eggs through months of darkness and temperatures reaching -40 degrees Celsius. Weddell seals dive to depths exceeding 600 meters, holding their breath for over an hour. Antarctic krill form swarms visible from space, providing food for whales, seals, penguins, and seabirds. Extremophile organisms discovered in Antarctica expand astrobiology's possibilities. If bacteria thrive in bloodfalls' ancient brine, perhaps similar life exists on Mars in subsurface aquifers. If organisms survive in dry valley soils, perhaps Martian soil harbors dormant life awaiting detection. Antarctic research directly informs strategies for seeking life beyond Earth. Understanding Antarctica requires patience and technology. The continent yields its secrets gradually through decades of sustained research. Subglacial lakes were hypothesized in the 1960s, confirmed in the 1990s, and remain largely unexplored. The Gambutsev Mountains were discovered in 1958, but their formation mechanism remained mysterious until recent seismic surveys suggested ancient rift valleys preserved beneath ice. This is exploration, as it actually occurs not dramatic revelation but gradual accumulation of knowledge, each discovery raising new questions, each answer revealing deeper complexity. Antarctica rewards careful investigation with genuine wonder. The continent harbors mysteries that decades of research have only begun to unravel. Lake Vostok's depths remain unsampled. What organisms live there, isolated for 15 million years? How have they evolved? What biochemistries have they developed? These questions await answers. The full extent of subglacial volcanic activity remains uncertain. How many active volcanoes lie beneath ice? How does their heat affect ice stability? Could increased volcanic activity trigger accelerated melting? The mechanisms governing ice sheet collapse are incompletely understood. What triggers rapid disintegration? How quickly can ice sheets respond to warming? What tipping points exist? Antarctica's genuine mysteries exceed any fabricated legend. Reality offers complexity and wonder that conspiracy theories cannot match. The continent reveals that patient investigation, rigorous methodology, and international cooperation unlock understanding that speculation never achieves. What exists in Antarctica surpasses what is imagined about Antarctica, and this truth makes the frozen continent more remarkable, not less. Antarctica is changing faster than at any point in recorded history. Satellite measurements show the continent losing ice mass. Between 2002 and 2019, Antarctica shed an average of 150 billion tons of ice per year. The rate accelerated losses in the 2010 to 2019 period exceeded losses in the 2000 to 2009 period by nearly threefold. The ice does not melt uniformly. East Antarctica, containing most of the continent's ice, remains relatively stable. Some regions are even gaining ice as increased snowfall adds mass. West Antarctica tells a different story. Glaciers draining into the Amundsen Sea are thinning and accelerating. Pine Island Glacier and Thwaites Glacier, together containing enough ice to raise sea levels over 1 meter, are losing mass at increasing rates. Thwaites Glacier presents particular concern. Its base lies below sea level on bedrock that slopes downward inland. Warm ocean water penetrates beneath the glacier's floating ice shelf, melting it from below. As the ice shelf thins, it provides less resistance to the glacier behind it. The glacier flows faster, thinning further, allowing more ocean water access. This feedback process could lead to rapid collapse. Computer models simulate possible futures. If ocean temperatures continue rising, Thwaites could destabilize within decades. Complete collapse might take centuries, but once begun, the process may be irreversible. The glacier's collapse would affect neighboring glaciers, potentially triggering broader West Antarctic ice sheet instability. The consequences extend globally. West Antarctic ice sheet collapse would raise sea levels by 3 to 5 meters over several centuries. Coastal cities housing hundreds of millions would face inundation. Bangladesh, the Maldives, Pacific Island nations would lose territory. Major ports, Shanghai, Miami, Mumbai, Lagos, would require massive infrastructure investments to remain viable. These projections contain uncertainties. Ice sheet behavior depends on factors incompletely understood: how quickly warm water reaches glacier bases, how ice responds to fracturing, what role subglacial topography plays in either slowing or accelerating collapse. Current models predict Antarctic contribution to sea level rise between 5 and 58 centimeters by 2100, a range reflecting genuine uncertainty about complex processes. As ice retreats, landscapes buried for millions of years emerge. Nunatak's mountain peaks that project above ice become more prominent. Valleys appear where glaciers recede. These newly exposed areas provide opportunities for geological study and biological colonization. Already, moss and lichen expand into regions where ice recently covered. Research expeditions plan to explore these emerging landscapes. What fossils lie preserved? What geological formations might reveal Antarctica's ancient climates? What minerals or resources might become accessible? These questions drive scientific interest, though the Antarctic Treaty's environmental protections prohibit mineral exploitation. Lake Vostok remains a primary research target. In 2012, Russian scientists drilled through the final meters of ice, reaching the lake's surface. Initial samples contained bacterial DNA, though whether from the lake itself or from contamination during drilling remains debated. Plans continue for deploying submersible vehicles into the lake to sample water and sediments, search for life, and study this unique ecosystem. The technical challenges are substantial. Equipment must be sterilized to prevent contaminating the pristine environment. The probe must function under extreme pressure in water that has been isolated for 15 million years. Communication through 4 kilometers of ice requires specialized systems. Yet the scientific payoff justifies the difficulty. Understanding life in Lake Vostok prepares us for exploring ice-covered moons. Europa, orbiting Jupiter, contains more liquid water than all of Earth's oceans. This ocean lies beneath an ice shell 10 to 30 kilometers thick. NASA and ESA plan missions to orbit Europa, map its surface, analyze its composition, and potentially land a probe that could drill through ice to sample the ocean below. Every technique developed for exploring Antarctic subglacial lakes contributes to these planetary missions. Enceladus, a small moon of Saturn, shoots geysers of water vapor into space from cracks in its south polar region. The Cassini spacecraft flew through these plumes, detecting organic molecules, salts, and evidence of hydrothermal activity conditions that on Earth support life. Future missions might sample these plumes directly, searching for biosignatures without even landing on the surface. Antarctic research on extremophile life informs what biosignatures we should seek. Advancing technology transforms Antarctic research. Autonomous underwater vehicles explore beneath ice shelves, mapping their undersides and measuring ocean conditions. These vehicles navigate independently for days, collecting data in regions too dangerous for human-piloted submersibles. The data reveal where warm water reaches ice, where melting accelerates, where stability might be maintained. Ground-penetrating radar improves with each generation. Current systems achieve resolution detecting features as small as 10 meters beneath kilometers of ice. They map subglacial water channels, locate buried peaks, and identify density anomalies. Future systems will provide even higher resolution, potentially detecting individual caves or geological features. Artificial intelligence analyzes radar data faster and more thoroughly than humans can. Machine learning algorithms trained on known geological features detect patterns in new data, flagging areas for closer examination. This combination of improved sensors and computational analysis accelerates the pace of discovery. Ice core drilling pushes deeper. The current record, 800,000 years from the Epica Dome sea core, will be exceeded by projects targeting ice over 1 million years old. Sites in East Antarctica contain ice, potentially reaching 1.5 million years. Drilling to these depths requires years of effort, specialized equipment, and careful handling to prevent contamination or sample degradation. Older ice means older atmospheres trapped in bubbles. Ice spanning 1.5 million years would bracket the mid-Pleistocene transition, a period when Earth's glacial cycles shifted from 40,000-year to 100,000-year rhythms. Understanding what changed in Earth's climate system during this transition could help predict how the system responds to current forcings. International collaboration intensifies. The Antarctic Treaty System continues expanding. More nations establish research stations. More scientists from diverse countries conduct fieldwork. Data sharing agreements allow researchers worldwide to access measurements and observations. This cooperation contrasts sharply with geopolitical tensions elsewhere, demonstrating that scientific collaboration can transcend political divisions. Private sector involvement grows. SpaceX, Blue Origin, and other commercial space companies develop technologies with Antarctic applications. Improved satellite systems provide higher resolution imagery. Communications networks expand coverage. Logistics companies offer transport, services. This commercial participation reduces costs and increases capabilities. Climate change transforms not just ice but also ecosystems. Southern ocean warming affects krill populations, the foundation of Antarctic food webs. Krill feed on algae that grow on sea ice undersides. Less sea ice means less habitat for algae, potentially reducing krill abundance. Declining krill impacts penguins, seals, and whales that depend on them. Warming allows new species to colonize Antarctic waters. Fish species previously limited by cold temperatures move southward. Non-native species arrive, transported by ships or currents. These invasions could disrupt ecosystems that evolved in isolation. The Antarctic Treaty includes protocols for preventing biological contamination, but enforcement remains challenging. Ocean acidification adds stress. As oceans absorb atmospheric carbon dioxide, water becomes more acidic. Shell-forming organisms like pteropods, small swimming snails that feed many Antarctic species, struggle to build shells in acidic water. Their decline could cascade through food webs, affecting species far removed from direct acidification impacts. Understanding these changes requires long-term monitoring. Research stations collect continuous data on temperature, ice extent, species abundance, and ocean chemistry. Satellites track changes visible from space. Ships conduct regular surveys. This accumulated data reveals trends that short-term studies miss, demonstrating how ecosystems respond to sustained environmental change. The frozen frontier ahead is one of transformation and discovery. Antarctica will look different in coming decades. Less ice, more exposed rock, altered ecosystems. But also more knowledge, more cooperation, more understanding of how Earth's climate system functions. The continent will continue revealing secrets, some through ice loss exposing what was hidden, others through patient research, uncovering what requires investigation to reach and comprehend. Challenges await. Technical obstacles must be overcome to explore subglacial lakes safely. Ethical questions arise about what interventions are acceptable in pristine environments. Political tensions could threaten international cooperation. Funding limitations constrain research ambitions. Yet progress continues. Each Antarctic summer brings new expeditions, new discoveries, new data. Each winter, scientists analyze what was collected, publish findings, and plan next season's work. The accumulation of knowledge proceeds steadily, expanding understanding piece by piece. Antarctica's future is being written by forces both human and natural. Greenhouse gases released decades ago continue warming the atmosphere. Ice sheets respond on timescales spanning centuries. Ocean circulation patterns adjust to changing inputs. Ecosystems adapt or decline depending on how quickly conditions shift. Human choices determine what future unfolds. Reducing emissions slows warming, giving ice sheets more time to adjust, limiting sea level rise. Continuing current trajectories accelerates changes, increasing risks of rapid destabilization. The difference between these paths is measured in meters of sea level rise, billions of people affected, and trillions of dollars in adaptation costs. Antarctica no longer seems as remote as it once did. Its ice shelves affect coastal cities worldwide. Its ecosystems reflect global environmental changes. Its research informs understanding of climate, life, and planetary systems. The frozen continent connects to everywhere, influencing futures that extend far beyond its icy shores. The mysteries ahead are genuine, not fabricated legends, but real questions awaiting answers through patient investigation. What exists beneath Lake Vostok's dark waters? How quickly can ice sheets collapse? What ancient climates are preserved in million-year-old ice? Does life exist on Europa, and will Antarctic research prepare us to find it? These questions inspire not through conspiracy, but through curiosity. They reward not speculation but investigation. They reveal that reality, properly understood through evidence and reason, exceeds any fiction in wonder and significance. Antarctica's frozen frontier ahead offers genuine discovery if we choose to pursue it with rigor, cooperation, and respect for truth. The Nazi Antarctic base legend persists not despite evidence against it, but partly because of that evidence. Consider how conspiracy theories function. They begin with a kernel of truth. Germany did send an expedition to Antarctica. They add ambiguous events. Operation Highjump terminated early. They incorporate dramatic elements, mysterious statements by Admiral Byrd. Then they construct narratives connecting these elements in ways that official explanations supposedly cannot account for. When evidence contradicts the narrative, conspiracy thinking has ready responses. Documents are dismissed as fabricated. Witnesses are accused of being silenced or coerced. Absence of physical evidence is interpreted as proof of perfect concealment. The theory becomes unfalsifiable. No evidence can disprove it because all evidence is suspect. This epistemic closure makes conspiracy theories resilient. They survive not through supporting evidence, but through immunity to contradicting evidence. Every challenge strengthens believers' conviction that powerful forces are suppressing truth. The theory becomes self-sealing, insulated from reality. Psychological factors drive this persistence. Pattern recognition essential for survival. Helping our ancestors detect threats and opportunities sometimes generates false patterns. We see faces in clouds, hear words in static, find meaning in randomness. This tendency, called apophenia, creates perceived connections between unrelated events. Confirmation bias amplifies this effect. We notice information supporting existing beliefs while dismissing contradicting information. Once we suspect a conspiracy, we find evidence everywhere. Ambiguous statements become confirmations. Coincidences become proof. Normal events become suspicious. Our pattern-seeking brains construct elaborate narratives from scattered data points. The narrative feels compelling because it provides simple explanations for complex realities. Why did Operation Highjump end early? Rather than weather, logistics, and tragic accidents, mundane but true, the legend offers dramatic conflict with hidden enemies. The second explanation is more emotionally satisfying, even if less factually accurate. Conspiracy theories also serve social functions. Believing hidden forces control events makes chaos feel more manageable. Random tragedies become part of plans. Inexplicable evil becomes explicable through secret cabals. This psychological comfort comes at the cost of accurate understanding, but for some, that trade-off seems worthwhile. Distrust of authority feeds conspiracy thinking. Government secrecy, corporate malfeasance, and institutional failures erode confidence in official narratives. When authorities lie about some things, and they do, it becomes easier to believe they lie about everything. Healthy skepticism transforms into blanket rejection of expert consensus. The digital age accelerates legend propagation. Algorithms optimize for engagement, promoting content that provokes strong reactions. Conspiracy theories generate clicks, shares, and comments. Social media platforms inadvertently create echo chambers, where believers reinforce each other's convictions while dissenting voices are filtered out or attacked. Lack of media literacy exacerbates the problem. Many people lack skills to evaluate sources, distinguish credible evidence from speculation, or recognize logical fallacies. A YouTube video with dramatic music seems as authoritative as peer-reviewed research. An anonymous internet post carries the same weight as documented history, yet dismissing conspiracy believers as simply ignorant or irrational misses something important. These beliefs often reflect genuine concerns poorly expressed. Skepticism toward government secrecy is justified. Governments do keep secrets, some legitimately and others to hide wrongdoing. The question is how to channel that skepticism productively rather than destructively. The difference lies in methodology. Healthy skepticism questions narratives while remaining open to evidence. It distinguishes between what is proven, what is likely, what is possible, and what is implausible. It updates beliefs when new evidence emerges. It recognizes that uncertainty exists without filling every gap with conspiracy. Conspiracy thinking, by contrast, starts with conclusions and selects evidence to support them. It rejects expert consensus not through superior evidence but through blanket distrust. It treats all claims equally rather than weighing them by supporting evidence. It cannot be updated because it interprets all contradicting information as confirmation of cover-up. Antarctica reveals this contrast starkly. The continent harbors genuine mysteries, subglacial lakes, isolated for millions of years, ice sheets whose behavior we are still learning to predict, extremophile organisms expanding our understanding of life's possibilities. These mysteries invite investigation, not speculation. The Nazi base legend offers easy answers that preclude investigation. Why wonder about Antarctica's actual history when you know Nazis built secret bases? Why study real Antarctic science when conspiracy videos provide more exciting narratives? The legend doesn't expand knowledge, it substitutes false certainty for genuine curiosity. Real Antarctic research demonstrates how investigation should proceed. Scientists propose hypotheses, design experiments, collect data, analyze results, and modify understanding based on findings. They collaborate across nations, share data openly, and subject conclusions to peer review. This process is slow, sometimes frustrating, often yielding ambiguous results. But it works. Our understanding deepens steadily. The Antarctic Treaty exemplifies what cooperation can achieve. 47 nations with diverse interests and ideologies agreed to use an entire continent for peaceful purposes. They set aside territorial disputes, prohibited military operations, and mandated environmental protection. They created mechanisms for resolving conflicts and frameworks for collaboration. This cooperation didn't eliminate national interests or geopolitical tensions, it channeled them productively. Countries compete for scientific prestige rather than territory. National programs maintain distinct identities while sharing data and resources. The treaty proves that even amid global tensions, humans can cooperate when structures support cooperation. The contrast with conspiracy thinking is instructive. The treaty succeeds through transparency, shared rules, and mutual accountability. Conspiracy theories thrive on secrecy, hidden knowledge, and unverifiable claims. The treaty builds trust through verification. Conspiracy theories destroy trust through unproven accusations. Which approach better serves human flourishing? Which expands understanding versus restricting it? Which builds connection versus isolation? The answers seem clear, yet conspiracy theories will persist. They fulfill psychological needs that facts alone cannot address. The need for meaning, for agency, for simple explanations in a complex world. Debunking rarely changes minds because belief isn't primarily about evidence. It's about identity, community, and emotional satisfaction. More effective is presenting alternatives that fulfill the same needs more constructively. Want meaning? Explore genuine mysteries through science. Want agency? Engage in citizen science or advocacy. Want community? Join groups pursuing knowledge rather than conspiracy. Want simple explanations? Recognize that simplicity isn't truth and complexity isn't conspiracy. Antarctica's story, the real story, offers all of this. It provides adventure through exploration of extreme environments. It delivers wonder through discoveries of subglacial lakes, ancient ice, extremophile life. It demonstrates cooperation through international treaties and collaborative research. It matters for humanity's future through climate connections and astrobiology implications. This reality exceeds any legend. Bloodfall's iron-rich brine is more remarkable than imagined Nazi bases. Lake Vostok's 15-million-year isolation is more profound than conspiracy theories about hidden technology. The Antarctic Treaty's peaceful cooperation is more inspiring than speculation about secret conflicts. The frozen continent teaches us that patience reveals truth, that cooperation achieves what competition cannot, that evidence accumulates through disciplined investigation, that genuine mysteries reward those who pursue them rigorously, that reality, properly understood, surpasses fiction in beauty and significance. We stand at a moment when these lessons matter urgently. Climate change shaped by Antarctic ice dynamics will affect billions. Misinformation spreads faster than facts, undermining shared understanding needed for collective action. Geopolitical tensions threaten international cooperation, just when global challenges demand it most. Antarctica shows another path, not through naive optimism but through demonstrated possibility. 47 nations maintaining peaceful cooperation for over 60 years proves it can be done. Decades of research, expanding knowledge shows that patience and rigor reveal truth. Discoveries from extremophile bacteria to ancient atmospheres demonstrate that reality rewards investigation. The choice is ours. We can pursue genuine mysteries with evidence and reason, or we can chase legends with speculation and assumption. We can build understanding through cooperation, or we can fracture into isolated communities certain of their own truth and dismissive of others. Antarctica will continue regardless of our choice. Ice will melt or persist based on physics, not belief. Subglacial lakes will harbor life according to biology, not speculation. The continent will reveal its secrets to patient investigation, not conspiracy theories. But how we approach Antarctica reflects how we approach truth itself. Do we follow evidence wherever it leads, accepting uncertainty, updating beliefs when warranted? Or do we select facts supporting predetermined conclusions, reject contradicting information, and insulate ourselves from challenge? The frozen continent has been a mirror throughout this narrative. It reflects human nature, our curiosity and credulity, our cooperation and conflict, our reason and irrationality. What we see in Antarctica depends on whether we look through evidence or through ideology. The real story is there for those willing to see it. Not hidden bases and secret conflicts, but subglacial lakes and international cooperation. Not suppressed technology and cover-ups, but extremophile organisms and advancing knowledge. Not mystery for mystery's sake, but genuine questions awaiting genuine answers. This is Antarctica's gift, not confirmation of what we wish to believe, but revelation of what patient investigation discovers. The continent invites us to embrace wonder without abandoning rigor, to pursue mystery while respecting evidence, to acknowledge uncertainty while rejecting unfounded speculation. The Nazi base legend will likely endure, evolving as new technologies enable new claims, adapting to each generation's anxieties and fascinations. But it need not dominate our understanding. We can recognize it for what it is, a story people tell, revealing more about the tellers than about Antarctica, and we can choose the harder, more rewarding path, engaging with Antarctica as it actually is, a place of extreme environments and extreme beauty, of international cooperation and scientific dedication, of genuine mysteries and patient investigation, of climate connections that matter for every coastline and ecosystem, implications that inform our search for life beyond Earth. The frozen continent awaits not believers or skeptics, but investigators, those willing to follow evidence, embrace complexity, accept uncertainty, and find wonder in reality itself. Those who recognize that the universe, properly understood through disciplined inquiry, exceeds any conspiracy in magnificence and meaning. This is the story Antarctica tells, if we listen carefully, think critically, and choose truth over comforting fictions. The continent endures, indifferent to legends, revealing itself only to those patient enough to look beyond speculation toward understanding, and in that understanding lies wonder exceeding any tale humans might invent about what hides beneath the ice.